Good afternoon, everyone. I'm Kelly. I would like to start with a little story and take you back when I was 14 years old. It was a regular school day somewhere in September, and I had my very first chemistry lesson. And right then, I knew something for sure. This is it. This is what I want to do. I want to study chemistry. I want to become a chemist. Some of you might now maybe think, chemistry? Really? Is she joking? No, I'm not. For me, it was different. The periodic table felt like a secret map. Atoms, molecules, chemical reactions, solids melting, liquids bubbling. It felt like entering a universe where nothing stood still, everything was transforming. Sometimes subtle, sometimes explosively. If you would have told 14-year-old me that one day there would be a connection between chemistry and the forest, I probably would have laughed. But that's what happened when working as a researcher at VITO. Walking through the forest, I don't see just trees or leaves anymore. For me, it's like looking at chemistry in action. Fluids, fibers, natural compounds with fascinating potential. Complex organic structures like cellulose, for instance, or something called lignin. Doesn't sound familiar? Don't worry, we'll get back to that soon. But let me first introduce Karolien, who has a totally different story.
Indeed, when she was dreaming about molecules, I was out there in the forest and climbing in the trees like as a hero girl. You know, the hero, it's like the Girl Scouts, but then better, right? Yeah. And when I go out in the forest, I like the smell of nature and trees. I enjoy to watch the plants grow to the light and see how life organizes itself in silence. Nature is like a language I wanted to learn. It is a system, a very complex system, yet calm. And it is not magic, but it felt like wisdom. And if I see a tree, I see biology building quietly, elegantly, taking its time. Exactly.
Yeah,
Now it comes. And I see strength as well, because if you go around hanging on the branches, it takes a strong tree. And I see renewal and circularity.
And these little stories explain why we are here today, the both of us. Two different paths, but one shared curiosity. She sees biology, I see chemistry. And together we call it Chemistree. It's our research and innovation journey where we explore how nature's own molecules like lignin can inspire the materials of tomorrow.
Because the moment you got up this morning, we start to use materials while brushing your teeth, dressing you up, moving to work or to youth camp. So everything around us starts with materials. And that's good. But there is also a few drawbacks, because the majority of these materials are still built of fossil resources or oil. They are often difficult to recycle, and they might contain toxic compounds, like often the cheap stuff you buy online. And do you remember, for instance, this loom band problem we had in 2014? So a lot of children were making these bracelets from loom bands at the time, and after a while it became clear that they actually contain toxic compounds. That's not so nice. And as the global population keeps rising, also does the amount of materials we need. And with that, the need for more ingredients, there is also more waste generation and more pressure put on the planet in general. And that's a problem. But it's also an opportunity. Because what if we can grow the materials of the future? What if some solutions are already out there?
Indeed, the materials we use every day and the forest have more in common than we think or even notice. Let me explain with a very simple example we all know and use every day: plastic bottles. A plastic bottle is strong, rigid, standing tall. But what causes this strength and rigidity? It's a special class of chemical compounds called aromatics made from fossil oil. But here's the twist. Nature has been building those same aromatic structures for billions of years. Trees do it just using water, carbon dioxide, and sunlight. No factory, no reactor, no waste. Just elegant, efficient chemistry.
And that brings us to lignin. It is a hidden glue inside the wood, deep inside it, a natural glue. Because lignin it holds together the layers of bark and wood, and it provides the tree its rigidity. It protects against invaders like pathogens and also ensures its efficient water transport. It is like the scaffolding and the shield all in one molecule. And that's great because lignin you actually find everywhere. It's all around us. It is the second most abundant organic compound on Earth. But today, still most of this lignin is actually being burned as waste. And that's a missed opportunity.
Although lignin is the second most abundant material on Earth, it's just not lying somewhere. As Karolien has described, it's deeply locked into the complex structure of plant cells. So in one way or another, we need to get it out. The process of taking lignin out is similar to something probably most of you do every morning: making coffee. And how do you do that? Step 1, you pour hot water over ground coffee beans. Step 2, you wait a bit. Step 3, you filter. Et voilà, a nice cup of a rich aromatic brew. Taking lignin out of wood works in a similar way. But instead of extracting caffeine, we are extracting lignin, a natural, dark, complex compound full of chemical structures and full of potential. But just as your cup of coffee can be a simple one or a fancy specialty drink, it's what we do with the lignin after that makes all the difference. To unlock its full potential for high-performant materials, we need to take it further. We refine it, we stabilize it, we functionalize it. But just to be clear, we are not reinventing the wheel with this processing of lignin. Just as the chemical industry refines crude oil into building blocks for plastics, materials, and fuels, we refine lignin into a new versatile ingredient, replacing fossil-based roots with circular bio-based ones.
So, do you believe us if we say that bio-based is not future technology? Because here's the thing, you're probably already using it. In your house, your walls, your floor, your packaging. You may not see it, but it's there gently shaping your world. Because bio-based materials are designed by nature and refined by science and technology. And from lignin, for instance, we create then glues, coatings, composites, and they have a low carbon footprint. They are often non-toxic, and they can either biodegrade or easier to recycle. Lignin-based materials, they are strong, durable, and multifunctional. And I'll give you a few examples. For instance, take insulation materials. Having walls that protect and insulate containing lignin. And yes, it may be brown and not white, but is that a problem for you? Or you put on helmets during sport because they need to be durable. They need to deliver essential functions like stiffness and strength. Or another example is with the rise of renewable electricity or energy, you have the wind turbine blades that spin on safe natural chemistry. That sounds cool, right? And a fourth example is protective clothes that resist fire, or festival fences as a more close-by example. And unfortunately, it reminds us of the main stage on fire last week. So it makes this topic more relevant than ever. And also lignin can add to the lifetime of the materials, so prolong the lifetime by adding antioxidant properties. And so this shows that these are not pipe dreams. These are prototypes, and some of these examples are already hitting the market.
It all sounds excited and promising, right? But here's also a reality check. It's not a plug-and-play solution. What works in the lab does not always survive the jump to the real world. Scale up is a whole different challenge. To move to full commercial production, we need to prove it works at pilot scale, reproducible, reliable, and safe. That's why we at VITO have invested in a dedicated pilot infrastructure, just to take that step, to produce the new building blocks out of lignin at pilot scale. And in this way, we also give the tools to others to push these bio-based materials further, to test them, to see if they can handle real-life demands. It's also not only about making the materials, introducing a material shift. It's a complete system shift. Because going bio-based isn't as simple as swapping molecule A for molecule B. To make it truly work, the whole value chain needs to evolve. From forest owners, processors, manufacturers, designers, consumers. Everyone has a role to play. Everyone has to believe in this shift, invest in it, and ultimately benefit from it. And yes, we are also hearing your questions. Won't that mean cutting more trees? Is it safe? Isn't it costly? These are the right questions to ask, and they deserve serious answers. Our answer? Use what's already growing around us. Use what's already out there. Nature gives us more than enough if we use it wisely. Think of waste wood from home renovations, agricultural residues after harvest, or forest thinning residues which would otherwise just be burned or left to rot. And then there is cost, economics, performance, safety. These aren't afterthoughts. They are part of every experiment, every decision, every step in the development.
So, how to make it happen now? Because a lot what we do relates to our wallet, to the euros you and I spend each day. And that's where policies can help. Right now, most policies still focus on biofuels, delivering energy from plants. But materials deserve just as much attention. So that's why we need rules that level the playing field, that promote material development, incentives for renewable content next to recyclable content. And Europe is also moving into this direction. Because if we want to make fair choices, we must do what's technically sound and ecologically right, but still at reasonable prices. And we are not always there yet. And that's why innovation is crucial. Because you want performant, functional materials, right? They need to be safe and reliable. And you want them to also work in times of crisis when the world goes crazy, like today. And that's why we innovate starting from biomass or bio-based resources. Because on a sunny summer day, 1 hectare of forest, which is around 2 football fields, let's say, it can grow more than 1 gram of biomass per second. That's amazing. And then we didn't even consider the potential of waste wood. So we just need to see and believe in the potential of these streams, of these resources, and use them to build in collaboration with nature and not in competition. Because the future is waiting, not in a lab, but out there, might already be growing. Thank you very much. And we want to capture this moment by a cool selfie. Oh, nee.